Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility, so this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
Today, we're going to be focusing on an incident that impacted network connectivity in the East US region. This happened on the 20th of March. Customers have experienced intermittent issues, including latency, timeouts, and even packet loss. While this incident predominantly affected traffic within one availability zone, which was availability zone 02, it represented about 10% of the regional traffic. And as a follow-on, we also had downstream services that were impacted, such as Logic Apps, Compute, and virtual machines, and app services.
Sure, right. So to talk us through the impact, our response on the day, and our learnings, I'd like to introduce a couple of engineering leaders joining us as our guests today. Joining us live in studio, we have Newton Sanchez. Newton is our partner and engineering manager. And joining us remotely from the East Coast, we've also got Frank Ray. Frank is our partner and general manager. Both Newton and Frank are from our Azure networking team, so they're the right folks to talk us through it today. Thank you for being here.
Absolutely. Frank, maybe we could start with you, if may. Thank you very much for joining us, by the way. I imagine that the hundreds of data centers that we have, the scale of our operation, we do maintenance events all the time. These are par for the course. And so maybe, but before we get into the incident itself, could you walk us through typically what kind of maintenance we were doing and how we generally recover, restore, rebalance traffic after these types of maintenance events?
Yeah, so thank you first of all for having me. So, on any given day, we have fiber maintenances and fiber events that are happening on a regular basis. Our alerting monitors everything. And then we see any events that happen and our automated systems respond to them. And all of these things happen in the background, completely transparent to our customers on a daily basis. And in this instance, there was a planned fiber maintenance that was happening in the Northern Virginia market. And to set the stage a little bit, like the Northern Virginia data center market, it's almost 5 times larger from a data center capacity perspective than any other single US market, which means there's a lot of fiber in the ground. There's a lot of events that are happening, and you think of the additional data center expansion and even regular residential expansion. There's always works that's happening, whether it's building something, expanding a road. And so there's constant planned maintenances that are happening with our providers on a daily basis. And many of these, we know about them, they immediately get detected. We go through our standard mitigation process, and then our capacity comes back online. And again, that all happens normally on a normal good day, transparent to anything that our customers can see.
Got it.
And as far as what we do to make sure that that's transparent, is we have a lot of our systems that do a bunch of checks and moving traffic around that I know Newton can cover as well.
Yeah, as Frank was saying, maintenance is a planned event. Is a few weeks in the future. We get an notification that we need to do it. We first verify with our providers that we have the exact geolocation for the work. Based on that, we know the fiber is affected. We put in our simulation systems that will figure out if that fiber is down, are we resilient enough? Do we still have the capacity and the headroom for our customers if a secondary event was to happen? So that all checks out and is repeated over the period of time between you getting notification and the day of. On the day of, we have instructions, we send instructions to the router saying, please drain the traffic from these circuits, put them on other circuits. We always have a lot of redundancy there, right? And prior to the maintenance crew engaging, when they finish, they give us the thumbs up, we do the reverse and bring the traffic back. And this is all while monitoring is going all the time, figuring out, do we have additional conditions that showed up that we're not expecting, right? Because the expectation is that there's no impact to any customer doing these events.
This all sounds good. So we've got a plan, we find out about it, we simulate things first, and then we go and do the maintenance and put the traffic back. You make it sound easy. So I was reading the post-incident review for this specific incident, and we mentioned that the scale and the nature of this region, just like Frank was talking about, required this rapid reconvergence, right? Lots of network paths, lots of network devices. Can you help us understand, Newton, maybe what does that reconvergence mean in practice? And why was the scale of the region such an important factor here?
Yeah, so basically, the life of a router is figuring out, for a given destination address, where do I send this packet, right? And the bigger the region, the more addresses you have, the more destinations you have. The bigger the region, the more paths and redundancies you have to send that packet. So those two factors combined give the router a lot more work. And the work is twofold. It has to communicate to its neighbors what it can do and what it cannot do, what traffic it can route, what traffic cannot. And it has to program its hardware to send a packet in the right direction. That's all done low level on the silicon, right? And those things are happening at the same time. The bigger those dimensions are, the number of routes and the number of neighbors, the harder it is for a router to catch up with big events. And when we actually are taking traffic away or bringing traffic back to a large number of routes that's affected by a maintenance, that's one of the biggest events the router will see. Much bigger than, say, one neighbor failing.
It's interesting, Newton, if I can stay with that for a while. We spoke in the PIR about a latent software bug that happened, but it only affected one type of router that we had. Could you talk to us a little bit about where this router is in our infrastructure, and why did this bug delay the rebalancing or the reconvergence of traffic?
Yep. So within availability zones, we keep a tight envelope on the latency between communication. So we have routers dedicated to transmitting data within data centers in the same availability zone.
Now, you brought a diagram along that kind of helps show this a little bit.
Yep.
So I know we talk about these regional network gateways that help connect availability zones, but you're saying there's an equivalent kind of gateway within each zone for distributing traffic to the data centers within the zone.
There is a availability zone gateway,
Right.
which has a bank of routers, a lot of redundancy there, and it connects to all data centers in that AZ. And the bigger the region, the larger the number of data centers within the AZ, and the larger number of routes to direct traffic to that they represent the customers in each of these data centers, right? So those two factors make this region unique by its size, and is one of the things that was a contributor that triggers for the issue that was latent on the routers.
Got it. Okay, so it's good to understand this. This wasn't something that affected a ton of different routers. This was some specific routers, and those routers architecturally were in a place that is distributing traffic within AZ-02. So it's not between zones, not between regions, just with the data centers within AZ-02.
Yes, and there's one more unique factor here, which is we've been, over the last year and a half, we've been trying to make the whole process of maintenance tighter and tighter, compressing the time frames to make sure that the customers we have the most capacity at all time for all customers. So all the work, the bookends of physical work, we're trying to make that tighter. And that improves the performance and reliability of the systems, the automated systems that touch the routers to program route traffic shifting away and traffic shifting back to a particular circuit. But in this case, it was a contributing factor. We're kind of a little bit victims of on hard work, in which, given the scale, plus the intensity of commands we send to the router to say, do all this traffic at the same time, right? Cause this triggered was another contributing factor for this latent bug to be triggered.
So we've been getting faster and faster at rebalancing traffic, but when we did it in this massive zone and speeding it up altogether, plus we triggered the bug, that's incredible. Okay, thank you.
It's good to understand some of those different factors of what contributed here, the scale of the region, the nature of the region, the interconnected nature of this maintenance, and then the latent software in one specific router. So we've got all those pieces together in our head. Frank, maybe we can bring you back in here. Would you touch on our kind of on-the-day incidents response, right? When I was reading the post-incident review, we said this was basically a 33-minute kind of period of networking pain, and some downstream services, as you mentioned, took longer to recover. Would you just talk us through the detection, the investigation, the mitigation? It looked like this self-healed. Did I read that right, that humans didn't actually need to intervene to fix this?
Yeah, so we had our network engineers on standby. As Newton said, we knew that this maintenance was going to happen. There's always risk that comes with touching anything within the network. So there were humans that were monitoring, but no human was needed to come in. So once the event started to happen, our auto detection immediately flagged out and sent out a response to saying that there's this incident that is happening. Our auto mitigation then started to kick in, and so by the time anybody needed to do any real intervening, the traffic had been moved and everything had all self-healed in that regard. But we did have our team there standing by as standard protocol during the maintenance.
So thank you very much, Frank. I find this incident so fascinating because we have these operations checker in real time to make sure things are happening. We simulate maintenance before we do them. That piece is kind of all automated. Then we bring it back online automated. It causes an issue because of the scale and because of all the things that we spoke about. But then the mitigation itself, the detection and mitigation, was all automated as well. There's been a ton of automation in here that cause problems, but also solve the problems as well. So as we pivot to our learnings and repairs, I'd like to click in on one or two of them. There was one where we spoke about, we said that we were going to create a new alert to find this type of, reading the syslog to find this kind of convergence bug. But when I hear about all the automation that's in place, what would finding this bug do? We already mitigated this pretty quickly without the need of human beings. What would be the advantage of finding this log and getting an alert from it?
Yeah, so we have kind of two classes of alerts. One, what we call a black box alert. We don't know what's going on, but we have synthetic traffic that we send data center to data center. Actually, we send it from any rack, any two pairs of racks. And we do a lot of statistical treatment there to figure out, are customers seeing issue? That's a proxy for the customer delivery. And in this case, that alert was the one that told us customers are seeing issues between data centers within this AZ. So we could localize it to that AZ, and that's what engaged the engineers. But we prefer to also tell them what's going on. Not only that something is going on, but what's going on. And now that we understand this latent bug that was discovered with our router vendor, right? We have a signature for it in the syslog, and we put that into our alerting system, so that the engineers get two things: something's happening, and this is happening, which makes their action much more precise. And that's also the way that we trigger any sort of auto mitigation when engineers are involved. When we have a precise root cause, that leads to a much more direct automated response.
It's great to understand. I like the way you frame that. So it's not just that there's something going wrong, but why there's something going wrong. And so it's not, I know we talked about it as a new alert or as more monitoring, but it sounds like it's actually enriching the information that we give the on-call engineers so they can understand it better. That's really great. That's the first repair item we touched on. The second one that we mentioned, we called it updating our operational procedures, which sounds a little vague, but what we're talking about here is when we're restoring traffic, we're going to try to do that in such a way that avoids this bug in the first place. You know, you talked about being a victim of our own success and how we do that very quickly. It sounds like this is just a short-term fix until we can get to the long-term kind of router fix. Have I understood that correctly?
So basically, we're undoing some of those that improvement we've done in terms of compressing the timeline, getting more time for the routers to breathe in between commands we're sending them, actually sending some additional commands that break the problem into smaller steps for them to climb through without triggering the bug. So we can do that through our management system, through automation, external to the software that's running on the router.
So when we say updating our operational procedures, we're not asking humans to do that differently. We're actually programming our tooling to thrash these routers less aggressively.
Yeah, as Frank says, like humans are supervising, but everything here is automated, including the day of, like on the clock, a few minutes or hours before the work window, the automation kicks in and manage traffic. Once the engineer sends a thumbs up, the automation kicks in and manages the traffic, terminate the traffic. That's all done through automation today.
That's fantastic. And it's cool. And just the staging of it all, just to not expedite as fast as we can, because we found it trips into issues with big scale regions. But one of the other repair items is we said we're going to work with this router vendor. And we said that we're going to work with this router vendor to get this bug fixed. And we said it's going to be done by June 2026. And I initially thought to myself, can we commit to that date? If we're dependent on a vendor, are we still confident on the date that we're going to get all of that fixed?
So yeah, we could say that because we already have the fix in-house right now since the incident. So we have the fix, and we're also going through the typical lab qualification, which followed by a pilot in some canary region, some place where the risk is lower, and then we start doing tactical deployments to the places of greatest need. And at some point, we do a global rollout. So the idea here is, like, because we have the fix on hand, we could be a bit more precise about this. And we have a lot of automation. All of our software deployment is also automated, right? So we know the dynamics of how long it takes to deploy. There's how long it takes to qualify, but having the fix on hand helps us be more precise there.
That's cool. So that the repair item ETA is actually already baked in, the time partnering with the vendor and receiving those bits and how long it takes to test, roll them out across the fleet. Okay, so I mean, we've touched on 3 different repair items. We've covered a lot of learnings in terms of what Microsoft could do differently. Frank, we also, in these sessions, we like to include what the customers have learned from this, right? We know that building reliable applications in the cloud is always a shared responsibility between the provider and the customer. And so we want to make sure that these learning sessions include, how could customers and partners have weathered the storm better here? The post-incident review mentioned availability zones as a best practice, but also some retry logic for any intermittent network issues. Would you mind kind of double-clicking on each of those for us?
Yeah, so as we always say in our documentation, having a zonal deployment is certainly the best BCDR. And as we saw in this event, the fiber maintenance and the impact was contained to a single zone. So the strongest things that customers can do is to follow Azure guidance and best practices to having a zonally resilient deployment for your workloads. In addition to that, there are certain network settings and configurations that customers could look at in their own networks if they wanted to. But yeah, some of your retry logic and timeout logics in your router configurations for your own network. But the real best practice here is to ensure a zonal resilient and multi-zone deployment for your workloads, and then those customers would not have seen anything happen on that day.
Got it. Those are both good.
As far as other systems, I do want to clarify for sure that we're saying here this 33 minutes represents the time for the network, which is obviously one part of the overall system. So there could have been customers that saw some additional time for other services that obviously leverage the network to recover. But again, the multi-zone deployment is definitely the best practice.
Got it. Yeah, that's helpful to understand. Those are best practices from a networking perspective, but obviously availability zones covers any of our PaaS services. They might have their own services or plans that let you opt into a zonally redundant configuration there. So always good to know for customers who found this, impacted their mission critical services. Maybe there are some levers to be able to be pulled that will help them be more resilient to this class of outage. So thank you for explaining that, Frank. I've saved my last question for my co-host Sammy. Since Sammy runs our incident communications team, how did we do on comms? Did we keep customers up to date?
But it's interesting. Typically, when we have incident retrospectives like these ones, we're dealing with major outages that last like an extended amount of time. What's been really interesting with this is that it was pretty much all automated, and even including initial comms to customers. So initial comms to customers went out through Brain, through a Logic app and app services and compute, and said, hey, there's an issue, it's an us problem, not a you problem. The issue was that once humans joined the bridge, the networking bridge, and once people wanted to find out a little bit more to provide to our customers, the networking component, as we've already discovered, was mitigated pretty quickly. And we knew that there was still residual impact to downstream services. So the first thing we did is put a banner on our status page. We typically communicate on our status page when there are major events, but this was mitigated and quite contained. But it took us a while to figure out what exactly happened. So we had to go. One of the challenges that we have with Brain, which is the automated communication system, is that it fired independently. It didn't understand that this Logic app issue is related to this compute issue, is related to this networking issue. And so we had to go and try and find all those incidents and correlate them well and then communicate to customers. That took time. And so we still have work to do in terms of investing in the idea to say, Brain, if we're seeing things that look like they're similar, we want to try and collapse those so that customers who are using multiple services don't get 2 or 3 tracking IDs, and then we have a third one with our networking thing. The other piece that was tricky is that when we communicated on a banner, we really wanted to communicate the zone that was impacted. So this was availability zone 02. Now, we don't offer that up to our customers. Customers have to have an API to run their subscriptions and say, my subscription mapping, when I pick 1, what does that mean? And that could mean 3, it could mean 2, it could mean 1, but there's an API there. So we have work to do. That's not a very helpful tool for customers, because when they pick a 1, on one subscription, it could be a different one to their other subscription. So we have an API to help, but there's some work we want to do in terms of communications and allowing customers to navigate some of their own environments when there's an impact in the cloud. Yeah.
Got it. So we get some points for being quick. So AI helped us on the early notification. Maybe AI still got some work to do when it comes to correlating those different
Absolutely,
events.
yeah.
Okay, that's great to understand. Well, I mean, thank you to Newton, and thank you to Frank for joining us to explain kind of what happened and what we're learning from this. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alert set up.
we really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.